Hello everyone. In this video, we will see about how to create algorithms. An algorithm is essentially a recipe or a set of instructions that outlines a step-by-step process to solve a problem or accomplish a task. Okay. So input and output for the algorithms, that is, algorithm operate on data. They take input data, process it according to their defined steps. You could see in this picture, and produce output data as a solution or result. Okay, so imagine an algorithm as a well-defined plan. It is like a recipe where you have specific ingredients, that is input data, and a sequence of steps, okay, the algorithm itself, to follow to create a final dish, that is your output data. Okay, so algorithms are used extensively in computer science and programming to automate tasks, solve complex problems, and make decisions. So they form the backbone of software applications, from simple calculations to sophisticated AI systems. Okay, so algorithms are the heart and soul of computer science, right? They are essentially a step-by-step blueprint for solving a problem. So think of them as a recipe, but instead of cooking a meal, they produce a desired output from a given input. Okay. So what is the purpose of algorithms is a blueprint for problem solving. The algorithms provide an structured approach to tackle a problem. They break down complex issues into smaller, manageable steps. And then communication tool. For example, by defining an algorithm, you can effectively communicate your problem solving approach to others. So it is a common language for developers and researchers. Before writing any code, having a clear algorithm is crucial. So it serves as a roadmap for your program. And once you have an algorithm, you can analyze its efficiency and look for ways to improve its performance. Okay. So for example, key characteristics of algorithms are: it should be finite, that is, algorithm must eventually come to an end. Okay, and each step should be clear and precise, leaving no room for interpretation. And the instructions can be carried out by a computer or a human. So algorithms take data as input, and they produce a result or solution as the output. Okay. For example, you can just think of this. Start with you have to find the largest number in a list of numbers. Okay, so algorithm for this, how it will be is, you have to start with the first number as the largest. Okay, then compare the current largest number with the next number in the list. If the next number is larger, make it the new largest. Okay, so repeat this again for the remaining numbers. The final largest number is the will be the result. So this is how an algorithm is created. And then you have, as I said earlier, you have this so there are some notations for creating an algorithm. So starting point is this initial step of the algorithm. It marks the beginning of the computational process. For example, you can refer it as a start. And then second step numbers, to maintain clarity and order. Each step in the algorithm is assigned as a number. For example, it is step 1, step 2, step 3, like that. It goes on. Input is data or information provided to the algorithm for processing. Okay, it is a starting point for the computations. For example, numbers, text, or arrays. Okay, and then next is the control flow. Determines the order in which instructions are executed. It involves decision making and branching. So keywords like if then else, or loops, for while loop. Okay, and then next statements. So these are the individual instructions that make up the algorithm. They perform specific operations. And then types in this is arithmetic operations, assignment operations, input or output operations, control flow statements. And then output, the result or information generated by the algorithm. It's the final product of the computational process. Okay, that is the output. And ending point is indicates the completion of the algorithm. For example, it is denoted as end. Okay, And then um, what are the properties of an algorithm and rules for writing an algorithm, we'll see. So algorithm is a sequence of well-defined instructions to solve a problem. It must possess certain properties to be effective, right? So first is finite. Algorithm must terminate after a finite number of steps. It should not run indefinitely. And then it should be complete. It should provide a solution for every possible input instance. And then the output produced by the algorithm must be correct for all valid inputs. Okay. And then rules for writing an algorithm to ensure clarity and effectiveness. So we can follow as consistency. Okay, that is use consistent notation and terminology throughout the algorithm. Well defined input and output, that is clearly specify the type and format of input data and the executed output. So language independent, that is avoid using syntax preferring syntax specific to any programming language. Okay, algorithm should be expressed in plain language or a pseudocode like format. We'll see what is pseudocode in next lecture. And then algorithm development process, you have 5 major steps. So step 1 is obtain a clear problem description. The first and the most crucial step is to thoroughly understand the problem, right? So it involves clearly defining the problem and its goals, identifying the inputs and expected outputs, determining any constraints or limitations. And then second step is to analyze the problem. So once you have a clear understanding of the problem, you need to analyze in detail. That is, break down the problem into smaller subproblems. Identify the which data structure required to represent the problem. Determine the potential approaches to solve the problem. Okay. And then third step is to develop a high level algorithm. So create a general outline of the algorithm focusing on the main steps involved. So this high level view helps in understanding the overall flow of the solution. Okay, so here use clear and concise language to describe the steps. And then step 4 is to refine the algorithm. Add more details to the algorithm, breaking down the high level steps into more specific instructions. So these step involves defining data structures and variables, determining control flow structures, for example loops or conditional statements like that, and refining the logic of the algorithm. And then step 5 is to review and test the algorithm. So thoroughly review the algorithm to ensure it is correct, efficient, and it is clear. Test the algorithm with different input values to identify and fix any errors. Okay, and then you can consider alternative approaches or optimizations if it is necessary. Okay, so this is the development process of an algorithm. And then just you have to consider this example and you have to create an algorithm for these problems. Okay, so first problem is to develop an algorithm for finding the largest integer among a list of positive integers, and second task is to algorithm should find the largest integer among a list of any values. Okay, and then third task, algorithm should be general and not depend on the number of integers. These are the given problem, and for this we have to create algorithms. Okay, let's see one by one. And for to solve this problem, we need an intuitive approach, right? So first use a small number of integers, for example 5, then extend the solution to any number of integers, then you can extend. The algorithm receives a list of 5 integers as input and gives the largest integer as output. So I have said the same example at the earlier. Okay, so here you are to grasp a concept of finding the largest number within a list, we'll begin with a simplified problem. Identify the largest number among just 5 values. So this will have a foundational understanding of this. So once we have established a solution for this smaller set, we'll expand our approach to accommodate lists of any length. Okay, so here initialization. So the process begins by taking an input list of numbers, that is here 12, 8, 13, 9, and 11. A variable called largest is initialized when the first value in the list, which is 12, right? And then comparison algorithm then compares the current largest value, that is 12, with the next number in the list as 8. Okay, since 12 is greater, largest value remains unchanged because largest is 12, right? And then next is comparison and update. So next number in the list is 13. As 13 is greater than the current largest value is now 12, it is greater, the largest is updated to now 13. Okay, and then you are going to continue this, and then it will be comparing the this proceeds to compare the remaining numbers, that is 9 and 11, with the current largest 13. Since both 9 and 11 are smaller than 13, largest value stays the same, that is 13 is the largest. Okay, so after examining all numbers in the list, the algorithm concludes the largest number is 13. Okay, so this value is then designated as the output data. Okay, so that is what has been given as the algorithm and the steps here. And finally, how we are obtaining the output by using this algorithm. Okay, that is what I have explained. You can go through this. And then second example is you have to print numbers from 1 to 20. How the algorithm starts. Okay, so first step is initialization. Sorry, start is the, so you have to begin the process. Okay, and then initialize x, so set the value of variables x to 0, and then increase the value of x by 1. Display the current value of x. If x is less than 20, go back to step 3. Okay, then if terminate the process once this x reaches the 20. Okay, and then next another example is you have to convert temperature from Fahrenheit to Celsius. So first again you will be beginning the process, input the temperature value in Fahrenheit. So use the formula C equals 5 by 9 star F minus 32 to convert the Fahrenheit to Celsius. Okay, so displace the calculated temperature in Celsius, and then finally terminate the process. So this algorithm, which demonstrates a simple mathematical calculation, it involves input, calculation, and output operations, right? So this example can be used to explain the basic arithmetic operations in programming. And then other example 4 is algorithm to add two numbers entered by the user. Okay, so first here you will be beginning the process. Create variables named number 1, number 2, and sum to store the input numbers and the result. Okay, so input two numbers from the user, that is we will be giving the numbers and store them in number 1 and number 2. Calculate the sum of num1 and num2 and store the result in the sum variable. So print the calculated sum, and then finally terminate the process. Okay, here you could see which demonstrates the basic input, calculation, and output operations. Okay, it involves using variables to store data and all. Okay, and then you can try this to write algorithm, that is to find the largest among three different numbers, and then you can try to find the roots of a quadratic equation, find the factorial of a number, check whether a number is entered prime or not, and then you can find the Fibonacci series. Okay, to just try to create algorithms for these problems. Okay, so thank you.